Number 4, what is the resultant vector? I hope you guys can see a pattern by now, where one is 138 degrees and 8.5 times 10 to the power 4. That is going to be our F1. And the other is at negative 60 degrees at 3.4 times 10 to the power of 7. That's going to be our F2. So I am going to draw our coordinates, and like I said, draw it big. So we have our positive x-axis, which is going to be 0 degrees. And then we're also going to have our positive y, which is going to be 90 degrees, right? So our negative x, that's going to be 180. And our negative y, that's going to be 270, right? Okay. F1, I'm going to do that in, I'm going to do that in black. One is at 138 degrees. So if this is 90 degrees and that's 180, I think 138 will look like this, where this right here is 138. So we have F1 going like that. We also have F2 where it's negative 60 degrees. So if our positive x is 0, we're going to go down 60 degrees, which would be something like this. Right here, this would be 60. And we would call this F2. So we want to find final F, right? But, oh man, should I do this in a different way? Nah, I think this is fine. I think you guys can get it. So I still don't know what, I don't know what F is going to look like. I don't know if it's going to be going over here, maybe going a little over here. I don't know. But what I do know is that F is just, okay, hold on. Okay. F is just going to be a line that's going to have a x component and a y component. So if I know what fx and fy are, I can solve for f. That is my ultimate goal right here. So I need to find what fx is. Fx, we can find that through the sum of the x component forces we have. So we have F1x and F2x. Let's find each of these. I'm going to write this part in red. So the x component of our F1, we go, since this is, oh, maybe I should talk about the angle first. Yes, this is 138, but we want to make a triangle. When we divide F1 into its y and x component, we get this y right here, and then we get the fx, f1x right here, right? This would be f1x, f1y, but be careful because I seem to always forget it. This needs to be negative because it's going left. That's the negative direction, right? And we have a triangle here, which means we need to find the angle. We know this is 138. We know that this is 90. So if we just do 138 minus 90, that would tell us that this angle is 48 degrees. So if we know this angle, we know what F1 is, and we're looking for F1x. I don't know if you guys can see that. It'd be like the cursive S would be sideways, but I know that it's sine. So F1x is F F1 sine 48 degrees. And I'll write that down. F1x was F1 sine 48 degrees. Oh, I did it again. I forgot about the direction that we're going. F1x, that's a negative, right? Because we're going left. I always forget that. F1 sine 48 plus, now let's look at F2x. F2x, this diagonal F2 has an x and y component. It has its x component going like this, and then its y going like this. That's not a very good triangle, but whatever. F2x, right? So we have our angle, we know our hypotenuse. We want to find this. We'd be using cosine, because like there's like the triangle, the C that goes like from here to here. That's just how I think about it. So it'd be F2x would be F2 cosine 60 degrees. And this one would be positive, right? Because it's going in the positive x direction. So I don't have to worry about that. It was cosine 60 degrees. Okay, negative F1 was 8.5 times 10 to the power of 4. 8.5 times 10 to the power of 4 sine 48, and F2 was 3.4 times 10 to the power of 7. 3.4 times 10, 7 cosine 60. Is that correct? I think it is. I'm going to put that in my calculator just in case. Let me see. Plus, oops, sine 48 plus 3.4 times 10, 7, and cosine 60. Okay, so we got obviously a really, really big number. I'm gonna just call it 1.69 times 10 to the power of how many? 1, 2, 3, 4, 5, 6, 7. Fx is this. So we found that. Now let's look for Fy. Fy is the sum of all of the y component forces. We have F1y and we'll have F2y. So let's try and find those. This is F1y, right? This right here. We know the angle, we know F1. So can you see the C? Can you see it be C right here? So it's like cosine. So F1y would be F1 cosine 48 degrees. Let's just look at F2y now, because we're here. This would be our y component arrow, right? That'd be F2y. So we have our hypotenuse and our angle right here. It's a upside down cursive S. Can you see that? It goes right here and here, so it's sine F2 sine 60 degrees. Okay, that's all we need. So F1y was F1 cosine 48, 40, oh, you guys can read that, right? F2y was F2 sine 60. I'm going to put an F1. Oh, I did it again. Did you guys notice? Oh, I wasn't thinking about the direction. I apologize. Which one is negative here? Which y component force is negative? It's F2y, right? So this right here is incorrect. I am not going to erase that so you guys know that I made a mistake. I'm going to just rewrite it correctly, okay? F1, that's going up. That's positive. I can keep that. F1 cosine 48 plus, it's plus because we're looking at the sum, but the direction is negative. So F2, y would be negative F2 sine 60 degrees. Okay, now we want to put in our numbers. F1 was 8.5 times 10 to the power of 4 cosine 48. 48 plus negative F2 was 3.4 times 10 to the power of 7 sine 60. Put that in your calculator. It should be, oh man, I'm not sure. I'm gonna put it in my calculator too. Hold on. Cosine. No. Okay. Sorry, it's gonna take time. Negative 3.4 times 10 to the power of 7 sine 60. Okay, I got an error. Why did I get an error? Oh, that's why. That still doesn't look correct. What am I doing? Hold on. Sorry about this. Cosine 48 plus negative 3.4 times 10 to the power of 7 sine 60. Okay. Okay, I think I got my correct number here. It's again a really big number, but we can work with that. And oops, oh, no, that's not correct either. Negative 2.93 times 10 to the power of 1, 2, 3, 4, 5, 6, 7. So that is our Fy. I'm just going to check if these seem to make sense. So I have a xy coordinate. We start from the origin. We have F1 going right here, but then we go negative 60, which is like here. So maybe our final force looks something like this. So I can guess that the x is Oh, I was gonna say x might be negative, but our fx value is positive. So at this point, I'm unsure if this is even correct, but let's just try and plug it in and see what happens. So we're looking for f, and I'm going to take the square root of both sides. Fy squared. And now I'm just going to put in the numbers we found. Fx was 1.69 times 10 to the power of 7. What if this was wrong? Oh my god. Fy negative 2.93 times 10 to the power of 7 squared. Can you see that? I'm gonna put that in my calculator. I'm hungry, sorry. You can hear my stomach. That's embarrassing. 2.93 times 10 to the power of 7 squared. Okay. I got something like 3.38 times 10 to the power of 1, 2, 3, 4, 5, 6, 7 newtons. And the answer that our teacher gave us said 3, actually, I don't know what it said. Did it say 3.4? Maybe. I'm just going to say it's 3.4 times 10 to the power of 7 newtons. That is our final resultant force. And should we look for the angle? Okay, let's look for the angle. Regardless of where this actual resultant force is, knowing that this is correct, I'm assuming that I should just kind of rewrite this. So we have a positive x of 1.69. So we go this way. And then we have a negative y. So we go this way. So maybe our final force looks something like this. And we want to find this angle right here. Last time I think I used tangent, so this time I'm going to use cosine to find the angle. So cosine theta would be, if this is fx, no, sorry. This is just f. This is fx. It'd be f under fx. Does that sound right? Yeah. Okay. And we're looking for the angle. I'm going to take the inverse of cosine. If you don't know how to do that on your calculator, just comment below. It's really easy. Fx was 1.69 times 10 to the power of 7 over f, which we found was 3.38 times 10 to the power of 7. I'm actually going to put that in my calculator this time. 1.69 times 10 to the 7 over 3.38 times 10 7 60. Okay, so we got 60 degrees. But we should be careful in writing this, because if this is our 0 degrees, this is going negative 60 degrees, right? So we can either call this like negative 60 degrees, or we can also just say it's 60 degrees. I mean, I don't know. I think we should just say negative 60 then. Oops. Oh my God, my stomach. I'm so sorry. Okay, negative 60 from the positive x-axis. It's going from here down 60 degrees. Yeah. Okay,